Alright, good morning everyone. Hope your day is going well so far. So today we'll continue with our sequences in series unit. We're going to talk about the partial sum of arithmetic sequences as well as geometric sequences. Okay. So for you to know, we'll introduce geometric sequences. And you have this geometric sequence right here, 2, negative 10, 50, negative 250, and 1250. And for part A, I want you to identify the common ratio, which is the constant that is being multiplied by. And then for part B, that is, I want you to write a formula for the nth term. Okay, so part A should be pretty easy. Part B, you have to think about that for a bit. But yeah, see if you can answer these, and we'll talk about it in, say, 30 seconds. Okay, so I'm going to pause you here. I'm going to go through the solution to the do now. Okay, so here it is. So again, part A is to identify the common ratio for this geometric sequence, which is the constant being multiplied by, and as you might be able to tell, right, 2 times negative 5 is equal to negative 10, and then negative 10 times negative 5 is 50, and then 50 times negative 5, etc. Okay, so the common ratio here is negative 5. For part B, where we had to write a formula for the nth term, and for this, it's a sub n is equal to 2, which is the first term in the geometric sequence, times negative 5, which is the common ratio, to the power of n minus 1. Okay, so again, we need that power of n minus 1, because just like the arithmetic sequence, our first term is called a1, not a0, so that does affect the indexing, right? And here it affects the exponent. And just to demonstrate that, right, for example, we can take the second term. In this case, it should be negative 10, right? So we're going to do negative a of 2 is equal to 2, which is the first term, times negative 5 to the 2 minus 1. 2 minus 1 is 1, so we get 2 times negative 5, which is negative 10. Okay, so it does work out. Now, if you took away the negative 1 here, right, you would have negative 5 squared, which would give you 25 times 2, which is 50. But that would give you a3. Okay, in this case. But yeah, if we start at a0, which we don't in our textbook, then you would just have n rather than n minus 1. Okay. But yeah, that's the answer to the do know. From there, we'll go on to talk about the partial sums of an arithmetic sequence. Okay, does anyone still need the do now solution? Okay, if not, then I'm going to go on to the slide then for partial sums of an arithmetic sequence. And here it is. Okay, could I get a volunteer to read this, please? All right, we'll go to Leo.
Partial sums of an arithmetic sequence. For the arithmetic sequence a sub n equals a plus n minus 1d, the nth partial sum is given by either of the following formulas. One, s sub n equals n over 2 multiplied by 2a plus parentheses n minus 1 close parentheses d. Number two, s sub n equals n parentheses a plus a of n over 2.
Okay, thank you for that. Um, so yeah, as you remember, right, from our previous lessons, right, for an arithmetic sequence, right, this is the formula we can use to find, any term in the sequence, right, and it makes sense, right? We just have the first term plus the index minus 1 because we start at a1, and then times the common difference, and that'll give you any term in the sequence. Okay. The nth partial sum is given by these, as you can see here. And this is actually, yeah, so it was derived on page, it was 835, I think it was, in the textbook. Um, but yeah, that's the textbook that, I would normally give out if we were in person. But yeah, as it is, here it is. Um, and there's actually a famous story behind this formula. Well, I'm not sure if this mathematician was the first person to derive it. I don't think he would be because it's uh, I think it's relatively intuitive, or not intuitive, but relatively simple, say, to derive. But yeah, the mathematician is Gauss, and you might have heard this, famous story of his school teacher wanted to assign this problem that would take the students a long time, right? So just the teacher wanted to have the students like add 1 to 100, just add all those numbers. But Gauss was able to figure out this formula by just lining up the numbers 1 to 100, adding them together to another pair of 1 through 100, and then, yeah, you get 101 times 100. But anyways, yeah, that's how we solved that problem. But yeah, that's uh, demonstrated by this formula right here. Okay. Does anyone still need this slide here? Okay, I'm gonna move on then. So next we're gonna just solve these two examples. Okay, so we're gonna find the sum of the first 40 terms of this arithmetic sequence, and then we're gonna find the sum of the first 50 odd numbers. All right, so let me scroll up for the solution there. All right, you're there. Okay. So here, for this arithmetic sequence, right, note that these formulas, right, from the last slide, they make use of the first term, A, right? Denotes the first term in the sequence, and then D is the common difference. Okay, so we're going to solve for that here. So here, the first term in this sequence, as you can see, is 3, and the common difference is 4, right? Because, to get from 3 to 7, you add 4. From 7 to 11, you add 4, etc. Okay, from there you just plug in the numbers. So I'm going to use the first formula here, and they want the first 40 terms, so that would be s of 40 is equal to 40 over 2, right, n over 2, n is 40 in this case, times 2 times a, which is the first term, 3, plus 40 minus 1 times the common difference of 4. Okay. From there, you just crunch the numbers. Outside the parentheses, you get 40 divided by 2, which is 20. And then inside the brackets, you get 6, that's 2 times 3, plus 39 times 4, which is 156. But yeah, after you multiply that through, you're going to get 3,240 as your sum. Okay, give you another moment to copy this, and then we'll go into the next example. Okay, next we have find the sum of the first 50 odd numbers. And here, so just think about this for a sec. They don't, explicitly give you the sequence, so we have to kind of think about what the first term is. It's going to be 1, right? A is 1, and then the common difference is going to be 2, right? Because from 1 to 3 to 5 to 7, the common difference is 2, right? So here, I'm going to use the second formula, this one right here. And for that, we need the nth term, right? So by the nth term, we need like a of 50, right? The 50th odd number. So yeah, that's going to be given by a sub n is equal to. So here we're using the formula from yesterday, right? So like, let me write it actually. So a plus n minus 1 times d. Right, so a, the first term in the sequence, is 1, right? That's the first odd number, plus n minus 1 times d. So let me actually change the order. In this case, it's going to be 2, right? But yeah, after you simplify that, you get 2 times n, so 2n minus 2. And it can be helpful if I actually write it out. 2n minus 2. Okay, so here all I did was just multiply through by 2, right? 2n and minus 2. And then we had plus 1 there. After you simplify, you get 2n minus 1, because 1 minus 2 is negative 1. So we get the nth term is a sub n. Well, I guess I technically could have just solved for the 50th odd number. I think that would have been easier actually. But yeah, I just, here we have this formula, so let's just use it now. So the 50th term, we plug in, n is 50. So we get 2 times 50 minus 1, which is going to be 99. Okay. From there, using this formula, we have n times a plus a sub n divided by 2. So n is 50, because we want to find the sum of the first 50 odd numbers, times 1, which is the first term, the first odd number, plus 99, which is the 50th odd number. Divide that by 2, and that's going to be 50 times 50, which is 2,500 as your answer. Yeah, actually, let me change that. I think we didn't need to do this. 1 plus 50 minus 1 times 2. That equals 99. Okay, so yeah. It's easier. Does anyone still need these two solutions here? Okay, if not, then I'm going to go on to our next part of the lesson, which is geometric sequences. And for this, I'm going to scroll down to the slide. All right, here it is. Okay. Could I get a volunteer to read this, please? All right, we'll go to Sayed.
A geometric sequence is a sequence of the form a, ar, ar squared, ar cubed, ar to the fourth. The number a is the first term and r is the common ratio of the sequence. The nth term of a geometric sequence is given by a sub n equals ar to the n minus 1.
Okay, thank you for that. So, we saw an example of this in the do now, right? And you also might remember this from Algebra 2, but yeah, geometric sequence is a sequence that's formed by, just you continuously multiply by a common ratio. And yeah, here's the formula. Should be intuitive, right? 8 times r to the n, but we have to subtract the power by 1 because our first term is labeled a1. Okay, does anyone still need the definition here? Okay, if not, then scroll up. Okay, so I think after this is just the classwork or the homework questions, right? But I'm actually going to stop here. So I'll go through these classwork homework solutions tomorrow in class. But yeah, so let me close with announcements. Again, same two things today. First, there's SGI 247 per usual. Secondly, reminder that our next and last quiz is this Friday, so please check Google Classroom for the topics list. Okay. But yeah, other than that, I'll let you go here, and yeah, I'll see you tomorrow. Have a great day and take care.
Thank you.
Thank you.
All right, you're welcome.